Hello everyone. We are going to now work on the next and final worksheet on chapter 10, which is on inferences for two population means. Now this corresponds to chapter 10.5 in the book. We do not have 10.4 in the syllabus. So if you're wondering, we covered previously 10.3 and we are going straight to 10.5. So if you're wondering whatever happened to 10.4, it's not in the syllabus, all right? We don't need to cover that. Now, 10.5, this particular worksheet is on paired samples, all right? So in paired samples, we are trying to compare the difference within each pair. All right, the overall difference within each pair, and therefore the difference has to be taken at individual levels. All right, previously we could have, when we were not working with paired samples, when we were just working with independent samples, we calculated, maybe in this case it's the husband and wife, we would calculate the age of all the husbands in our sample, find the mean of all the ages, and then we would find the mean of the ages of all the wives, and we would subtract the two means and take it from there. This one being a paired sample, we will need to take the difference at each individual pair in the sample. All right. Now, this problem was introduced as part of the lecture on chapter 10. Please go back and look at it. But this is also a problem from the book. So if you are reading the book regularly, then you will have come across this problem. All right. But it is the comparing the difference in ages between husband and wife. All right. So below are the ages of 10 randomly selected paired samples. So we have 10 couples in our sample, out of which population 1 represents the age of husbands. These are all ages. So let me pull up my pen here. All right. So this is population 1. And then the wife has been assigned as or defined as population 2, and these are the list of their ages. So when we take the difference, you see the difference is taken at each individual pair level. So look at how it's calculated. 59 minus 53 is 6. So the age difference between the husband and wife for couple 1 is positive 6. That means the husband is 6 years older than the wife. That's what it means. For the next couple, the husband had an age of 21 and wife was 22. So in this case, it's a -1. The difference is -1. And that means because it's negative, population 1, that's husband, is smaller in age than the wife. Okay. His age is lower than that of the wife by 1 year. Now, the difference we are going to denote with this italicized small d, all right? And then we are going to calculate each difference between the pairs, and then we are going to sum it up, and we are going to come up with what we call the mean difference. All right, the mean difference. Now I have a column here for d squared, and I'm going to tell you shortly why we need this column based on the formula we're going to use to come up with our test statistic. But let's just go on to answering some basic questions to formulate the problem. It says identify the variable under consideration. Now, since we are doing the study of comparing the age difference between husband and wife, our variable is going to be age. All right, variable is going to be age between husbands and wife. Identify the two populations. So we'll have population 1, which is going to represent all married men, that's husbands, all married men or husbands in the US. That's our population from which we drew the sample for population 1. All right, so all married men, which represents husbands in the US. So we are only considering, our study is only concerned with the age of married men in the US, and population 2 will be the all married women or wives in the US. However, we have to make sure that in our sample, we choose the wife of the husband that was chosen in sample 1. All right, that's in sample 2, the wife has to be the legally married wife of the husband that appears in sample 1. Now identify the paired difference. So the paired difference is going to be the difference in age, between a husband and his wife All right, so we have to keep them separate and identify them as pairs. All right, this man, all right, has to be aligned. Husband A has to be aligned with his wife because we are comparing their age difference. Part D says, are the numbers in the table paired difference? Why or why not? Yes, they are paired because the way they are arranged. Yes, since we are subtracting the ages or the age of the wife from the age of her husband, okay, it is a paired difference. All right, so that's how you're going to answer these questions. Now we come to performing the hypothesis test. It says, at the 5% significance level, do the data provide sufficient evidence to conclude that the mean age of married men differ from the mean age of married women? All right. So again, here the key word is differ. All right. So based on that, our alternate hypothesis will be formulated, will be stated. So step 1, state the null and alternate hypothesis. Again, this is a study in difference. We are comparing proportions. So we will be saying H sub O colon, this is mu, right? So mu sub 1 equals mu sub 2. Null hypothesis in the case of comparing two means will always say they are equal. There's no difference between the ages or between the two variables means. An alternate hypothesis is going to say mu 1 is not equal to mu sub 2. Again, why not equal to? That was obtained from the question because you said, what did it say here? That we want to conclude that the mean age of married men differ. So when the word differ comes, that means we are saying that they are not equal. All right, and therefore this not equal sign. Now, based on the alternate hypothesis, it's going to be a two-tailed test, right? Mu sub 1 not equal to mu sub 2. It's going to be a two-tailed test. So our alpha, all right, let's write again over here. It's two-tailed. So alpha, which is at 0.05, has to be split into 2 by virtue of it being a two-tailed test. So it's going to be 0.025. So when we do our critical value approach, this is how our reject and do not reject regions are going to look. For a two-tailed test, the reject regions are going to be on both sides of the curve. So this is going to be let's just define the regions first. The two end partitions, the two ends of the normal curve are going to be reject regions, and in the center it's going to be do not reject. But what is going to be the demarcation between the reject and the do not reject? So the area of each reject region is alpha by 2, correct this? So alpha by 2 equals 0.025, and this cutoff or the critical value is going to be negative z of 0.025. Well, this is a difference in mean, so I'm sorry, I'm going to erase this. We are going to use the t distribution. All right, it's going to be negative t of 0.025 with a certain df. All right, with a certain df, we are going to calculate that. And on the other side, which is also has the area of alpha by 2 equals 0.025, is going to have a positive t of 0.025 with the same df, all right, df, but we have to figure out the formula behind the df for paired populations, all right, and I'll just mention it here. If you recall, we discussed when we were doing our lecture. In the lecture slide, you can look back in the lecture, or rather, I'm sorry, in the PowerPoint lecture video, you can look that up. We said df is equal to n minus 1 for paired differences, for paired populations. All right, so we are going to use that formula. N here is 10, right? We have a sample size of 10 couples. So n is going to be 10, therefore df, all right, therefore df is 10 minus 1, which is 9. All right, so these df values will be 9 when we calculate our critical values. But let's move on. Step 2 is about identifying alpha, which is at 0.05. So if they're asking you for the alpha value, it better be in decimals. Please do not write alpha equals 5%. The significance level is 5%, but when you are asked for alpha, it better be in decimal, because alpha represents area under the curve, and the area under the curve is a value between 0 and 1. It cannot be less than 0, it cannot be more than 1. And because it's a two-tailed test, we'll have to find alpha by 2, which we've already done there, and that's 0.025. Now we come to step 3, which is about calculating the test statistic. Now, let's look at the formula. It's T equals D bar. Now, anything with a bar in it means mean. So it's asking to calculate the mean difference divided by the standard deviation of the difference, divided by square root over n. Looks neat formula, all right? Especially after what we encountered in the previous sections of this chapter. And we'll denote it as T sub 0. However, we have to calculate what D bar is. D bar means mean. So to calculate D bar is mean. So the formula for that is the difference, sum of the difference of all the samples we've calculated here, right? All these differences summed up. So this is our sigma D, all right? Sigma D divided by n. That's the formula for any mean, all right? Normally we work with x bar. It was sigma x over n. So let's do the calculation. Sigma D we saw was 36 when we added up all the differences. N is 10, so D bar is 3.6, all right? That's the mean difference in age between men and or husbands and their wives, 3.6 years. That's D bar. Now we have to find S sub D, which is the standard deviation. So S sub D is the same formula we use to find the standard deviation. We learned that way back at the beginning phases of statistics 1. All right, keep in mind that those are some basic statistical calculations you should be knowing at this time, at this stage of statistics 2 level. All right. The formula for standard deviation is this. I'm going to write the computing formula because it's so much faster. All right. So S sub D will go by this formula. Square root over sigma D squared minus sigma D whole squared, the sum of D squared, divided by N over N minus 1. All right. Now, we have to just find the values for sigma D squared. We know what sigma D is. It's 36, right? We all use that in the formula to find the mean. But so we can find that value and just plug it in here. And N is, we know, is 10. All right. So all we need to do is calculate sigma D squared. Now, to find sigma D squared, what we do is we go back to our table here and square each D value and then sum up. That's sigma D squared. So 6 squared is 36. Now, whenever you are, just a second, let me get this back here. Right. Okay. Now I'm ready to calculate our D squared values. 6 squared is 36. -1 squared. Any value squared is always a positive value. Please keep that in mind. -1 squared is +1. -3 squared is +9. Positive 4 squared is 16. So negative or positive, when squared, will always give you a positive number. All right. So make sure you don't put any negatives when you square a value here. All right. 6 squared is 36. -2 squared is +4, then 1, then 16. 13 squared is 169. All right. And 8 squared is 64. Sum them up, and that's going to be, all right, your sigma D squared. And that's 352. All right, it's going to be 352, and this is N actually. All right, so we got our sigma D squared value. It's 352. Let's now fill in all our variable values. So S sub D is going to be sigma D squared is, 352 minus sigma D is 36 squared whole squared divided by 10 over 10 minus 1 is 9. All right. So once we do this calculation, we will get an S sub D value equals square root over this whole expression under the radical will come to 24.7. You can try it out yourself as well to make sure that it agrees with what I have or mine agrees with what you have. If it doesn't, let me know. All right. So we have 4.971 and that's our S sub D. So we got our D bar. Our D bar value equals 3.6 and our N is, how much was it? 10. Right? So these are the values we will need to find T sub 0. So T sub 0 D bar is 3.6 divided by 4.971. 4.971 divided, all right, this is a division sign. Please don't multiply. Even though they are next to each other, there's a division sign in between. So make sure you write it a little bit below. So to remind yourself, it's a division involved. Square root over 10. So T sub 0 should come up to a value of 2.29. All right. When you do this calculation, 3.6 over this 4.97 divided by square root over 10 should come up to 2.29. So that's our test statistic all right, test statistic or the evidence. So now we go on to perform our, and I'm going to move this up a little bit to get some space here. Just bear with me. Okay, so I think we have enough space to work with the critical value approach. Now, this is our normal curve. It's a two-tailed test, so our reject regions would be on both sides of the curves. There's reject, there's reject, there's do not reject, right? And this area, again, we drew the same picture above, so it's no harm repeating it as that and reinforcing this in you. So these are the critical values, right? Positive t of 0.025 with df equals 9. All right. The formula for the df for paired samples is df equals n minus 1. Excuse me. Just a second. All right, df is n minus 1. All right, so, and this side, on the left-hand side, it will be negative 0.025 with df equals 9. And we come up with a critical value of 2.262. All right. So the CV, it's going to be negative 2.262 and positive 2.262 on the right hand side. So let's write that down. The critical value CV of T of 0.025 with DF equals 9 is plus minus, all right, plus minus 2.262. We bring our test statistic value, all right, which is T sub 0 of 2.29 is kind of in between. Well, 2.29, right? It falls on the reject region. Where does it fall? Let's identify that. 2.29 is greater than 2.262. Therefore, it falls in that way. It falls slightly to the right of 2.262, which is the reject region on the right hand side, correct? So let's write that 2.29. All right. And it falls in reject region. Therefore, reject region, therefore reject the null hypothesis. All right. That's going to be our decision. Now, to use the p-value approach, we have to start with our test statistic value, right? So let's do that here. Our test statistic T sub 0 was 2.29 and it had a DF of 9, correct? So let's draw our curve and try to show the p-value on the curve. When we are finding the p-value, we don't need to worry about creating the reject and the do not reject regions, right? What all we need to do is locate 2.29, which is the test statistic value on the on our scale here on our diagram. So it's positive 2.29. If 0 is here, then 2.29 is going to be way to the right, maybe somewhere here. 2.29. Extend the line to touch the curve, and the area that falls to the right, okay, this area is going to represent the p-value. Now, this is a two-tailed test, correct? So let me clarify that. If it were a right-tailed test, then the p-value would be whatever area this is on the right-hand side. If it were a left-tailed test, then the test statistic would be located to the left, and the p-value would be the area to the left of that particular location. If it's a two-tailed test, then find the area to the right. In this case, because 2.29 is on the right-hand side of the curve, find the area to the right-hand side of that value, and then you have to multiply it by 2. It has to be doubled. So in other words, this is going to be kind of the p divided by 2 value in a two-tailed test. All right, so before we compare p with alpha in the next step, we will just have to multiply it by 2, just because it's a two-tailed test, right? So it's going to be, let's put negative 2.29, although negative 2.29 is not our test statistic. Again, just because this is two-tailed test, p-value or half of the p-value would lie on the left-hand side. All right, I hope that is clear. So if you look up your tables, then it'll be an estimated p-value. However, I'm going to use my graphing calculator, and sometimes you can also search online to find the p-value. There are some virtual p-value calculators online, but you won't be able to do that on tests and exams. All right. So I've used my calculator, and I find that this area to the right-hand side is roughly 0.023. Oh dear, hold on one second. Where am I? Oops. All right, okay, I'm sorry, I'm back here. 0.0, and let me lock this, 0.0235 approximately. All right, that's the area of this right-hand part of the 2.29, which is our test statistic. And of course, it has to come with a D, because it's a T test statistic. It has to have a DF, all right, the DF9. So when you are looking for the area, then you have to, of course, put in the value of the DF and also the value of the T, and that'll give you an area of 0.0235. But because it's a two-tailed test, like I said before, you have to multiply it by 2. So the p-value is 2 times 0.0235, which is equal to, so that once we do the multiplication, it's 0.047. All right, that's the p-value. You compare, okay, the final step, you compare p and alpha. So the question you're asking is p less than alpha? So p is 0.047, alpha is 0.05. So alpha is less than 0.05. So p is less than alpha. All right, yes. Therefore, we reject the null hypothesis. And that should agree with our results we got from the critical value. Again, I ended up losing the writing for the critical value. So just backtrack a little bit on the video to check how we worked out the critical value. So the decision, therefore, is to reject null hypothesis. And like I said, you do need to interpret it, even if they don't ask you. The final steps is interpretation. All right, so at the 5%, significance level, because we rejected the null hypothesis, we are going to say the data do provide sufficient evidence, to conclude, so I'm going to go back to my question and get the verbiage from there. It says, to conclude that the mean age of married men differ from the mean age of married women. So let's do that. The mean age, to conclude that the mean age of married men differ from the mean age of married women. All right, so that completes the hypothesis testing for this problem. There'll always be a second part to this, which is to find the confidence interval. So if they're asking us to find the 95% confidence interval, and that confidence interval will contain the difference between the ages of married men and married women on a population-wide basis. All right, so the difference in the mean ages of married men and married women for all US adults, not for the sample, for all US adults. So first we have to come up with our alpha, which is derived from our percentage confidence interval. So alpha is going to be 1 minus CL. So 1 minus 0.95 is 0.05 alpha by 2. For all confidence interval problems, you have to divide alpha by 2. So it's going to be 0.025. And let me just quickly again go over this. I've done this many times, especially when we were talking about, when we were learning the first time about confidence intervals. I showed you with a diagram what this whole confidence interval and alpha mean, right? So confidence interval is the probability of finding the population mean, the difference in this case, the population mean, the probability of finding the probability, let me rephrase this, the probability that the population mean will be contained within that interval, the probability of that. And when we talk about the 95% confidence interval, that probability is 0.95, and that 0.95 is the area bounded by the end points of the interval, right? And the area outside that bounded region, is what alpha is, right? That's alpha, which is 1 minus 0.95. It's the area outside the bounded region, so it's going to be 0.05. However, the area on each side, on each end of the curve, of the interval, is going to be alpha by 2, which in our case is 0.025. Alpha by 2 is the area on each side. You have to divide equally. You have to divide alpha equally into 2. That's what it is. Step 2, it's find T of alpha by 2. So in this case, it's T of 0.025. But there's always a df associated whenever we talk about T. So with df equals 10 minus 1 is 9. So that value is going to be, let me look that up quickly. That value is 2.262. Okay, we found that when we were doing our, or finding our critical value. So it's going to be 2.262. Now that we have our T of alpha by 2, you just have to plug into the formula. This is the formula for the confidence interval. D bar was 3.6 plus minus. T of alpha by 2 is 2.262. We found our Standard deviation, again, just backtrack to see how we found our standard deviation. So S sub D is 4.971 divided by N is 10, so square root over 10. So here we are finding our confidence interval, right? The endpoints of our confidence interval. So 3.6, when we do this calculation of the margin of error, it's going to be plus minus 3.55. So the confidence interval is going to be equal to 0.046 to 7.15. All right, so that's our interval. Again, do not forget to interpret it in the right manner. You're going to start for confidence interval. You're going to start saying we can be, or we are 95% confident that the mean difference in age, between men, or rather between all US married men and women, that's MEN, and women, will be contained in the interval, and then just state your interval. In the interval 0.046 to 7.15. So that means that, again, we are talking about difference here. That means the difference in age between the husband and wife, the mean difference in age, will be anywhere between 0.046, which is a few months, to about approximately 7.15 years. All right. So that's how you will be working out the confidence interval and finally interpreting it.